joining this talk on data observability. I know that the title of the talk was a little chunky, but once I wrote it, I realized that maybe not everyone knows what this whole talk is all about. And so I prepared a bunch of slides, but I would like to keep it a little bit more back to the basics, because it probably is the first time many of you would hear from a data observability company, but you must have seen a lot of articles and a lot of news and a lot of and some demos here and there, and you must be wondering, what is it all about? How can it help me? And why now? Why is this important? Why should I use it as a practice? Why should I talk about it in my companies or in my, or do even a POC with a company like us? I'll also try to put some experiences that we have had building a company like this over the last 5 years, and then we can keep some time for questions. And I'll try to keep it because my observation that data conferences seem to be a slightly serious affair for some reason. Okay, good. Okay, so a little bit of introduction. Axel Data is a 5-year-old company founded in 2018 in Bangalore here, and right now we are based out of both the US and India. Our CEO Rohit, he works out of the US. I'm the CTO. My name is Ashwin, and I work out here at Bangalore. We have a team of close to 250, going from 4 people. When we started, we were 4 people in a WeWork right here near Kormangla. And now we have kind of grown to this size. We have raised close to 100 million plus along the way, a bunch of investors, observing 500 plus petabyte of data. I'll explain what this means in a while, but you should take it for face value as of now, right? And what do? We build a data observability platform, and this is where essentially most of our leadership team comes from, okay? So before I start, I'm going to ask you a series of questions. Depends on how long you've been working in tech and how long you've been in Bangalore. You might know one or many of these things. Who here has been working in the tech industry for at least 10 years? Not bad. 15. Wow, just 4. Who knows about this thing called WebLogic? Huh? Heard about it? Who's worked with WebLogic? Wow, 1, 2. So the reason is that before we understand observability, we can move on slide. We'll tell you a little story. I started my career in 2005, and my first job was actually writing ETL applications and reporting applications, okay? And in those times, it was for a travel company, and their data used to be in a database called DB2. Who's heard of DB2? Who's used DB2? Okay, 2 people, 3 people. So once in a week, you used to get all this information from DB2, and there used to be a job running in ETL. I think there was an Informatica person who came, so I'll not badmouth them, but Informatica ETL designer who used to come and used to design this ETL. And his daily operations, mode of operations was that he used to come at 9 a.m. in the morning and used to have a desktop and open Informatica Designer. Designer used to be written in this thing called Eclipse Foundational Framework. It's a Java-based service. Open it and then go play TT. Because it would take half an hour for that application to. And then he'd go and change one, mapping somewhere and then save it. At the end of it, there used to be another application called Cognos BI Designer. Who knows about this? Oh yeah, there are 4 people. Not bad, not bad. So Cognos BI Designer used to drag and drop some reports, and then you get a report. And then the customer would call. He said, "Hey, the report is not accurate. What do you want to do?" There's no time because it takes half an hour for the application to load. So you would right-click the XML file which Cognos BI generated and edit the SQL right there. Now, once you edit the SQL, the thing will not open in the design. So that was the world people used to program in, right? It was a kind of a walled garden. You used to live and die inside kind of proprietary frameworks. And it's the same is true for WebLogic. You used to be a Java developer or a C# developer. There was no data engineer. There was no data scientist. The LLM AI guy was not even born, okay? And you used to come in and you used to launch program against WebLogic, you had WebLogic documentation, then you deploy into WebLogic. There used to be somebody who is the WebLogic deployment configuration guy. You used to give the package to him. He would go. Then then there was an incident. You need to debug the logs. The logs will come in 3 days because you have to raise a request, right? Then you get WebLogic. Compare that to now. What has happened? What has happened is essentially that a lot, I like to call it democratization of the whole technical delivery environment. So now if you're a developer, I am a Haskell developer. I will join a Haskell company and I will build some software and I will deploy it inside a containerized service, and then I'm going to put it on Kubernetes, which I will use from Rancher, and then I will put it into Azure factory, and then I'm going to have it serverless. And so the combinations of things that you can use over the last 15 years from the time that I started my career in 2005 has essentially increased. It's like a buffet which is outside, right? You're a developer, you say, oh, I want to write in a startup. You can actually pick. You can pick a startup based on what technology they use. That's the amount of choice that you have. And because of this proliferation of choice, let's call it, you also have a problem of observability / monitoring / knowledge. What is happening when I build my software in Ruby on Rails and deploy it on service and put it on a container and put it on a cloud and use Postgres, put it somewhere, I have no idea when it goes wrong. Look at the connection pool, should I look at the, the pod sizes, should I look at the cloud, should I look at cloud cost? So over the years, a lot of companies have come out in which the primary use case of their existence is that they provide observability for a complex ecosystem like application development. Because it has become so complex now, the primary one, we like to think some top, not really based on reality, but at least we know that $250 billion plus of value has been created just in observability for logs and metrics and application servers, right? And which are these companies? These are all the companies which are available to you. Some of them you can use, some of them you have to buy a license, some of them will not talk to you unless you're a big enterprise. But overall, you see a huge spread of companies which provide observability across the modern, let's call it the application. So, can we name some? Top of the mind, who uses Datadog? Let's see, in their companies. Not so bad. New Relic, Prometheus, Grafana, right? So many. So the fact is, even though you might be in some data engineering field, but you're very used to observability solutions, it is almost intuitive. You will catch a developer and you'll say, hey, I saw your code, I'm reviewing your code, where are the log lines? Where is the metrics? Where are the traces? It is as fundamental as the practice of writing code itself. And anybody who does not write logs, does not use observability tools to monitor the services, is not, let's say, what you would call a rock star developer. Okay, so that's the story, and that's all about what I call the observability landscape. Next slide. And so I wanted to call it, I took it from a corporate slide, so don't mind some of the language, but right, as data engineers or the data engineering practice, what are we actually doing? This is the journey of what you would face if you go and talk to a big company. So take a customer of ours. T-Mobile is a big telecom company, is a customer of Accelerator. And if you ask them, what are you doing? They say, okay, I have a team of about 250, 300 data engineers, data engineering team. And what do? They do everything. They still have ETL. They still have those user interface. This is what we call, complex and expensive operation load. It's too slow. They have been doing cloud formation for the last 5 years, right? Or maybe 7 years, I don't know. But you ask someone, what is your company doing? Oh, we are in the cloud transformation journey. How long it has taken? Just since AWS launched, people are in the cloud transformation journey. The 5 years they'll be there. And now they're saying, it's too expensive. Let's go back to the data center, right? Modernization. Oh, this thing takes too long to load, like I said. So we want to use modern software. People want to use something a little bit more flexible, where you can optimize on the velocity, because now instead of one person, you have 250 people. And if 200 people are all waiting in the morning for your environments to load, then you're not going to get much productivity out of it. Therefore, we need modern tools, modern data stack. That's what Probably something you've heard as well. And the latest cool thing, generative AI. How many of you actually bought the ChatGPT license? $20 a month. No good. This is a very, very poor sample set. Me also. Four of us out of this team. How many of you have used the free version? How many of you actually use it every day? You should buy the license, right? I mean, yeah, company should give it to you. Oh, you have that? Oh, that we also gave it to our. How many of you think prompt engineering is a job? Want to be a prompt engineer? No one? Oh yeah, there are two people who want to be prompt engineers. Okay. But you go to our customers, you talk to them, some part of this 250 people is actually doing generative AI. And they're saying, hey, we want to use LLMs. We are going to do into an LLM transformation, the AI transformation. It will take how long? Since once the cloud transformation finishes, is when the generative LLM AI transformation starts. It takes another 5 years, and all companies, when you go, they'll have no agents. You want to get you get an Apple iPhone from the US, you come back home, you have an eSIM. What do? You have no people. Somebody from Airtel is going to answer your questions, some generative AI, and then you're going to get an answer. So this is the landscape of what is actually happening. What do your customers care of? This is what customers care about. You go to a company, this is what people will talk to you about. What are your data initiatives? Generative AI, platform modernization, so on and so forth. And so, this is what I was talking about. Earlier, I think we can go all the way. This is for, the animation is it's a little bit too much. So this is what we were talking about, right? I don't know why I said 1995. So 1995, you used to have simple applications, simple databases. I hope you can see it down there. And you had few tens of GBs being used. Then came Hadoop. How many of us have used Hadoop? Have used in the sense, have used written map reduce jobs and things like that. Wow, that's a good set. Yeah, we used to do. I came out of Hortonworks, so it's very nice to see this. Of course, everybody uses Kafka, Cloudera, HBase, also SAP HANA, which was built on top of this data, essentially pulling data out of these data sources, putting it out, creating some jobs, getting a lot of value out of it. We say that observability was difficult and manual. How do you? I was talking to Ashwin before, that observability is very close to him, close to his heart, right? Because he's been dealing with data all the time. And so, but in the Hadoop stack, the observability was really hard. Because it was open source, you really sometimes, MapReduce job would fail. You had no idea what was going on. Why did it fail? What happened? Then you log into a server, then you look at the logs, and then it says, oh, the RPC something. Take it and you paste it on the internet. You get to the Hortonworks community center, and then you try one by one. Hopefully you'll get it. Okay, but idea is observability is manual. And this is the state of affairs that we are in today, that what we are calling the modern data stack. There are a lot of logos here. Some of them Kubernetes, Jupyter, Lambda, Delta Lake, Spark. I'm sure a lot of us here are using in some form or fashion this set of tools. There are many new companies as well. We have, in our own cohort of friends and who are doing startups, many of them are trying to build. You heard from E6 Data, that's another parallel technology. Dipstack, another technology which you would want to probably add to this complexity. And so what I wanted to talk about, which I took so long to get to, is that the journey of what we heard earlier about how building APIs, building web services, is largely like going to a buffet. You can pick what you want to do, how you want to build. The data stack also is evolving in a certain way, and the evolution is that you have a lot of choice today if you want to build a data application. You have gone from the days where one person with one tool taking so long to load, come to a place where you have so many possibilities of combinations of things that you can use. We had a customer recently. They had the data lake on S3. There was a security incident. And they said, okay, now we are doing the whole thing as a re-architecture. And so they're and selected a completely different stack. And they came back to us and said, okay, now you have to support this stack. And so that's the amount of choice that is available in the market today. You really can try it out, figure out what you want to do, pick from any of those things, and then build your applications. And that's what, people really care about. And we are saying this is an operational nightmare, because the more choice, the more complexities, the more you need monitoring, more you need observability. Next slide. Exactly same thing talked about. These are some instances of people talking to us, some from the internet. The Harvard Business Review, you would have heard this a lot of times, that only 3% of companies meet basic data quality needs. How does this actually impact? There is something called the US FTC, which is a government entity in the US, which has certain punishments which are melted out to companies if you don't meet a certain set of standards. So if you are a company who's in the business of selling data to people, for example, healthcare data, business data, insurance data, and if you don't meet certain standards, you get fined by this entity. And if 3% of companies don't meet certain quality standards, then it's highly likely that things might go in a certain direction where there might be compliance issues. So some of these things are very important. A lot of feedback we have had from customers where they say, hey, this stack is too complex, we don't know who's spending, somebody wrote a query, it went on too long, now there's no capacity, the credits have run out, cloud is too expensive, can you hybridize it somehow, can you run some in the data center, can you run a lot of such aspects. And in general, most of our customers talk about the fact that we hired someone to write a data pipeline. Is anybody from Accenture here? Oh, okay, we'll say Infosys then. Okay, so we hired, anybody from Infosys here? Okay, no, good. So we hired someone from Infosys, wrote up a data pipeline. It took about 1.5 years, and they used a bunch of technologies. And now we don't know why something is slow, because most of our work was done by somebody else, right? And these are the kind of issues that you encounter when you talk to enterprises. Next slide. And so now I come to the main part of my talk, is that this is essentially what you will face in the stack. It's largely sort of the prime deliverable for any data team is sort of we can call it a data pipeline. You're collecting data from a lot of sources. You're sending it through a bunch of different layers. Some of it we have written down, said, okay, there's a landing zone, we put it, maybe it's S3. Maybe you're getting it from Salesforce, maybe you're putting in S3, then you're putting some additional data there. Then you set it up for some consumption. Usually it's dashboard, Tableau and Looker dashboards. Products, you can get a loan these days. Quickly you can go and say, I'm eligible for a loan. That probably is doing some data mining. Most likely was mined through this process. Some data was got, and that's how you get that information. That's an example of a data product. And a lot more we will see in the future for AI and ML products, right? Because if you want to send all your data to an LLM, expect it to answer some reasonable questions, then I assume that the data you feed it should be reasonable data. Then otherwise it's going to answer some junk. And so you got to keep clicking. And so problems start appearing, right? And so you see what happens. All of these problems start showing up. Performance, spend, of course, you're on the cloud, drifts, quality, data reconciliation, pipeline health, a bunch of issues which many of you would have faced in some way, one or the other. The schema changed, the data changed, the quality is incorrect, the dashboards are not refreshing, one or many of these problems which are obvious to people who do data engineering. Now, what is important to understand is that there is very less in common you would see in a Prometheus Grafana dashboard, because that application is largely the 90% use case, what you would say is latency. Why is something slow? And therefore, I will dig deep and find out that my connection pool is saturated. Therefore, I will dig and find out that the order service pod is down, something like that. But the primary driver is why is something slow. It is nothing very a data engineer's life. A data engineer maybe largely does not really care about why is something slow because the action is not transactional in nature. And so this is what we think is what data engineers care about. Next slide. And so what do? We say that observability for data means, you got to click. Yeah, so this is what a lot of observability companies do. This is not useful, extra, etc. Sorry. And this is what we do. So we say, okay, you need to have some sort of data quality automation so that you have redundancy, better handle on cost, make sure you don't over provision. You keep clicking. Oh, sorry, go back. Okay. There was more animation, I don't know where it went. But the whole idea is that you need to fix all the problems that was there in the previous slide. And that's where data observability comes in. It is an end-to-end approach where you want to make sure that you're addressing the concerns of the data engineering workforce and not solving one problem. Because one problem in Accenture might not be the same problem, right? You have a problem where you're trying to build some ML models, the data quality is not fine. The other company is just the Snowflake costs are exploding, queries are slow, right? How do you do it? You don't really go ahead and bring a solution to the market which solves one problem. Then that's not a platform, that's a point solution. Data observability, just like Prometheus, Grafana, Datadog, is a holistic approach where we try to address the concerns of the data engineering organization in general. Good. I wanted to bring a couple of use cases because we are an enterprise. There's something I found very interesting. Many of you might be working in different domains. I picked up two. And if you look at this trend, and this is something you can actually do, you can say domain analytics market, telecom analytics market, healthcare analytics market, e-commerce analytics market, whatever, some analytics market. And you will always see this trend that it's always growing and it's going to keep growing. And therefore, the data field is very exciting going in the future. Picked up two, talks about telecom from some research firm. Same research firm says the healthcare analytics market is also going to grow. Again, billions and billions of dollars. There's a lot of scope to be actually had. And so how does this look in practice? So this is a screenshot I took. I know it's not very clear, but I'll explain what is going on. This is from a customer of ours, and I hope I did a good job hiding all the details. I think I did. That this is actually the data coming in, right? So these are all the files which land in the data. And this essentially is close to about 7,000, 8,000 individual files landing in the data lake and close to 1 billion rows being added every hour. That means close to 25 billion rows which keep getting added, right, every day for one data set. And that's the scale of the enterprise. So if you look at all of this, what does it mean? It looks very similar to the graph which you saw earlier. So even on a granular scale, which is daily data, if you use a software like ours, which does data observability, that the data is actually growing. It is growing every day. We can plot it for every month. Unfortunately, we have been working with them not yet a month, but you'll see it that it keeps on growing. And it follows the trend which I talked about earlier, that more and more and more data is going to get generated in every single domain which we really care about, and more data will. But the way to then think about it is the bar on top says that for every hour, I'm looking at about 1.5, 1.6 billion rows in data. And I'm trying to figure out if this data is actually anomalous, and the bar at the bottom says that, hey, we found some anomaly, and you need to go and investigate, tells you there's some problem. So the is that even for something as basic as data coming into your data lake, there are trends and patterns and problems that you can identify. And so from there, if you expand, We say, okay, how do we process this data? How do you move this data? How do you stage this? Can I create reports on it? And so if your data landing on your data lake is not correct, it's not pure, it's junk, there's an issue with it, then of course your reports are going to go bad. If then you say, oh, data is the new oil, we'll use this report to invest, then that investment is also broken. That's the value of really data observability in the market. We have had customers who have, over the years, the amount of data has been added, and they had a reporting application which used to take about 2 hours for them to validate, saying, hey, everything looks good, we can send this to customers. That kept on increasing and reached 22 days, right? So now, over the years, the same report on the data set now takes 22 days to verify. Now, if one report takes 22 days to verify, then you can imagine that that methodology cannot really scale. And therefore, bringing in data observability into your own data engineering teams, not as a software, not as a tool which you want to buy, right? Because a company like ours is evangelizing it, but think of it as a practice essential as observability or logging is in when you're writing some code. You need to write observability. And therefore, we at Accelerator think that data observability specifically for larger engineering teams where there are big, classic big data ecosystem where there's a huge volume of data, there's a huge impact of incorrect data, impact of data projects not completing. Data observability is not so much of as a or a company, but it is a practice. We hope to be the reference implementation of this practice. And so, okay, we'll talk a little bit more, almost done. How do we build for scale? This is something we have tried. When we build, we see that there's a lot of data to be crunched. I talked about billions and billions of rows. So the way we have architected for scale is that we split the control plane because everybody wants to use the software on cloud these days. We offer a cloud service. Most of the data crunching actually happens in the customer's end. We call this the data plane. If you have used something like Databricks, you must be very familiar with this model where you use the software in the cloud, but the actual computation is running in your own environment in some place. So we have a very similar architecture, and that's how we are able to run at this scale at this point in time. Now, if you connect back to my original slide where I said there's 500 petabyte plus of petabytes of data that we observe, and like I showed you in the previous slide, that the volume, once you start looking at big teams and big data, is really large, and you need to prepare for that. And so what can data observability do for you? Essentially, automate your data operations. You want to do that anyways, do that anyways, but it keeps breaking, and therefore you don't know why something is breaking, but you can automate most of it. Now you can go become modern, do your transformation faster, like how we talked about earlier. It's not now a matter of years. You possibly have a way, an approach where you can do it faster. And of course, any presentation needs to talk about AI. So we say we can make your data AI ready with data observability. That's all. Thank you. Do I have time? I don't know. Yeah, okay. 2 questions. I think to do anything with data, the first thing you need to do is build a catalog. You need to do it. Whether you build a good catalog or you buy a catalog, but every product should have a catalog, right? Anybody who builds anything on data will have some list of things. That's what the metadata collector does. It goes and looks at data lakes, it goes and looks at data sources, looks at databases, and figures out which database, which column, what's the data type, what is the distinctness, what's the frequency, what is in it, does some statistical does, as opposed to open telemetry, which is largely meant for telemetry data. One more. Yeah.
So this data quality portion, is it like SQL driven, or you have your own UI to build data quality? How do you import or develop data
Okay, I think I got the question, but I'll repeat it. Quality function, the same SQL function, or do we have?
Yeah, basically, do they use the business users set it up, or how UI friendly it is, or how do they integrate with their existing pipeline?
Got it. Yeah. So I'll talk about how our approach to doing it. Right. Data quality means many things to many people. So you have something called a fill rate, null rate, and some of our customers would say, hey, my data is coming in an array, and in the array, in the seventh element, in the seventh nesting level, there is another array which has all the states which this is applicable on, and you need to figure out whether Wisconsin is on this list, something like that. And so the approach to that would be, our approach to that has been, yes, there is a self-serve kind of a UI where you can create it, but most companies, most serious companies, will end up having very complicated rules. And that requires you to actually author it in the best way to author something complicated is actually a programming language. So some sort of a user-defined function where people can express languages they know, for example, Python. We also have, one of our customers said JavaScript. We are comfortable. Why JavaScript? And so they say, because we are comfortable writing code in JavaScript. Okay, so JavaScript, somebody writes that rule that gets injected as a part of the pipeline, and you can trigger it in positive, and you can trigger it as a part of the existing pipeline as well.
I guess the following questions for the later part of the track.
All right.
Thank you.
Thank you so much for your time, and